All right, let's dive into this paper.
Okay.
RELINE, Aligning Vision Language Models via Retrieval Augmented Direct Preference Optimization.
Catchy title.
It is, and it's a paper that's really looking at this problem of VLM hallucinations.
Yeah, these, you know when a VLM looks at a picture of a cat on a sofa and says it's perched on a cactus?
Right, exactly.
That's the kind of thing that we're talking about here.
Yeah, those hallucinations. And they can be really funny sometimes.
Yeah.
But obviously,
They can be
pretty serious if we're thinking about real-world applications.
Yeah, if you're using it for something important, it starts hallucinating.
Yeah, exactly.
That's so good.
So how is Realign trying to make VLMs more reliable?
Well, so the key thing here is that Realign is focusing on these cross-modal inconsistencies.
Okay.
It's kind of like, bridging the gap between what the VLM sees in an image and what it says about it.
Okay.
So it's trying to iron out those inconsistencies to prevent those hallucinations.
Okay, so the paper talks about existing solutions for this, like DPO,
Right.
direct preference optimization.
Yeah.
But points out some of their limitations.
Yeah.
Like some of them are really computationally expensive and difficult to scale up.
Yeah. Imagine having to manually correct every hallucination.
Right. Yeah. Be a nightmare.
That would be a very tedious task.
And then other methods are trying to almost trick the model
Yeah.
by changing the image in some way.
Right.
But then that can create hallucinations that are too obvious.
Yeah. You're kind of teaching a kid about a cat by showing them a cartoon cat.
Yeah.
And then expecting them to recognize a real cat.
Exactly.
Not quite the same thing.
So how is Realign taking a different approach?
So Realign is doing something really clever with what's called image retrieval.
Okay.
So imagine giving the VLM like a spot the difference challenge.
Okay.
They find an image that's similar enough to the original to cause a bit of confusion, but different enough to trigger a hallucination.
So almost like showing them a picture of a fluffy dog instead of a cat.
Exactly, something that shares some features with a cat, but is ultimately a different animal.
Right.
And that can kind of trip up the VLM and lead it to hallucinate.
Okay, so almost like by doing that on purpose, they're then able to control it and train it.
Exactly. It's like setting little traps to see if the VLM will fall for them.
Gotcha.
And by using both the original image and this retrieved image, they create what's called a dual preference dataset.
Okay.
And this dataset then makes the VLM better at distinguishing between real and hallucinated details.
So it's like showing them the real thing and a fake thing,
Yeah.
so they can understand what's real and what's fake.
Exactly.
Okay, and there's another concept here, rDPO.
Yes. Retrieval Augmented Direct Preference Optimization.
Can you break that down a little bit?
So you can think of DPO as a way to kind of align the VLM's responses with human preferences.
Right.
You're basically saying, hey, this response is good, this one is not so good.
Right.
But with rDPO, you're adding a visual component.
Okay.
It's not just saying that the answer is wrong, it's also showing why it's wrong.
Okay, so it's like saying it's wrong, and here's the evidence for why it's wrong.
Exactly.
Gotcha. So that must help the VLM learn and adjust its understanding much quicker.
Exactly. And what's even cooler is that they actually put this to the test.
Okay, so let's get into the nitty-gritty of the experiments.
Yeah.
What VLMs were they using?
Yeah.
How did Realign actually perform?
So they tested Realign on a variety of VLMs, different sizes, different architectures, things like Alava, Janus Pro.
Okay.
They even used benchmarks specifically designed for hallucination, like PPO-P and Hallucination Bench.
Right.
So they really wanted to put it through its paces.
And how did it do?
Well, the results were pretty impressive.
Okay.
It consistently outperformed the other methods at reducing hallucinations.
Okay.
And in some cases, it really significantly reduced those nonsensical outputs.
Wow.
But here's the kicker. It didn't sacrifice performance on general VQA tasks.
But-
In fact, it actually improved performance in many cases.
Oh, wow.
So you're getting the best of both worlds.
So it's not like a trade-off where, it's less hallucinating, but then it's worse at everything else.
Exactly. It's better at hallucinating and better at answering questions.
That's amazing.
So this is where things get really interesting, for all of us working with VLMs.
Yeah.
Because Realign isn't just a theoretical concept, it's actually something that could have a real impact.
That sounds like
And that's what we'll be exploring further in the next part of our deep dive.
Definitely stay tuned because we're just getting started.
We are.
All right, so we've established that Realign's doing some pretty cool stuff.
Yeah.
Tackling these VLM hallucinations.
Yeah.
But let's break down a little bit how exactly it's achieving these results.
Okay.
I'm particularly interested in the whole dual preference data set.
Right.
So can we dig into that a little bit deeper?
Absolutely. So remember those spot the difference challenges?
Yeah.
So that's a great analogy for understanding how this dual preference data set is actually created.
Okay.
It all starts with, your typical image and text instruction.
Yeah.
Like,
Okay, describe what the woman is holding in this photo.
got it. So you've got an image and you've got a question.
Exactly.
That happens next.
So then the researchers use a top-notch VLM to generate what they call the chosen response to that instruction.
Okay.
So in this example, the chosen response might be like, the woman is holding a bouquet of sunflowers.
Okay.
And that's kind of our gold standard, our ideal hallucination-free answer.
All right. So we've got our ideal response.
Yeah.
Where do the rival images come into play?
Okay, so here's where things get interesting.
Okay.
They apply what's called strategic masking to that chosen response.
What does that mean?
So imagine taking our perfect answer
Okay.
and strategically removing words or phrases that relate to, key aspects of that image, objects, attributes, relationships.
So you're saying like mask out sunflowers and have it be like the woman is holding a bouquet of, and then blank.
Exactly.
Yep.
So now they take this masked response
Yeah.
and they go and they dive into a big image database.
Right. And they search for images that are visually similar to that original photo, but different enough to potentially cause a hallucination.
So instead of showing sunflowers, they might be showing roses or lilies.
Exactly. Images that share some visual characteristics but differ in those crucial details.
Right.
And then they use a separate VLM that's prone to hallucinations
Okay.
to complete that masked response based on these new images.
Got it. Okay.
So this second VLM, looking at a photo of a woman holding roses, might confidently declare
Yeah.
that the woman is holding a bouquet of roses.
Right. Even though in the original picture, she's holding sunflowers.
Exactly. And that becomes the rejected response, the hallucinated answer based on those misleading images.
Okay. So we've got the original image.
Yeah.
We've got the chosen response, which is our ideal.
Yeah.
We've got the strategically masked response,
Right.
the rival images. And then finally, the rejected response based on those misleading images.
Exactly.
It's like a whole recipe.
It is. It's like a whole pipeline.
But how are they then using this to actually train the VLM?
Right. So that's where rDPO comes in.
Yeah.
Retrieval Augmented Direct Preference Optimization.
Right.
So they use this data set
Yeah.
to fine-tune a VLM, basically train it to distinguish between those chosen accurate responses and the rejected hallucinated ones.
Okay.
And they're leveraging both the original image and the retrieved image during that training process.
So it's kind of like saying, look at the details, don't jump to conclusions.
Exactly. It's making the VLM more discerning and less susceptible to those inconsistencies.
Okay, well, that's great in theory.
Yeah.
But did it actually work?
Right. The results speak for themselves.
Okay, good.
They tested this on two major hallucination benchmarks, POP and Hallucination Bench.
Okay.
They used several popular VLMs, including Alavier and Janus Pro, and guess what?
Lay it on me.
Across the board, Realign consistently outperformed existing methods in reducing hallucinations,
Really?
sometimes by a significant margin.
Wow, that's great to hear.
And here's the best part. It didn't come at the expense of performance on general VQA tasks. So they tested Realign on a bunch of those benchmarks too, like Science QA, Text VQA, and others.
So it's not making them dumber in other areas just to get rid of the hallucinations.
Exactly.
So what were the results like there?
In many cases, Realign actually improved performance on those general tasks.
Really?
So we're talking about a VLM that's more reliable and more capable.
That's amazing. So it's not just fixing this one specific problem.
Right.
It's actually enhancing the overall understanding.
Yeah, it seems like it's really understanding the connection between visual information and language.
That's fascinating.
Now, the paper also gets into the different types of VLMs they use, specifically image-to-text models versus unified models.
Can you remind me what the differences are between those?
Sure. So image-to-text models are kind of like specialists.
Okay.
Their primary job is to take an image and generate some form of text output, like a caption or answer a question.
Right.
Unified models are kind of like the multitaskers of the VLM world.
Okay.
They can handle both image-to-text and text-to-image tasks. So did Realign work equally well on both types of models?
Yeah, that's what I'm wondering.
Well, here's the thing. Realign was effective at reducing hallucinations in both image-to-text and unified models.
Okay.
But the degree of improvement did vary depending on, the model's size and architecture.
Okay.
For example, they saw some pretty substantial improvements on smaller unified models like Janus Pro 1B,
So it sounds like Realign could be particularly useful for those smaller models.
That's one of the key insights from their experiments.
Okay.
But the overall takeaway is that it has the potential to improve reliability across a wide range of models.
That's good news.
Yeah. Now, there's one more technical detail I wanted to highlight before we move on.
Right.
Remember that discussion about inducing hallucinations at the segment level rather than the sentence level?
Yeah, I was wondering about that because most methods focus on the sentence level.
Right.
Why did they do that?
So their argument is that by focusing on segments, you get a much more precise learning signal. You know, if you're only looking at the sentence level, you might miss those subtle hallucinations within a sentence.
Right.
So, for example, imagine a VLM describes a picture as the dog is chasing a blue ball in the park,
Right.
when the actual image shows a red ball.
Right.
At the sentence level, everything seems okay.
Yeah.
But at the segment level, dog chasing blue ballpark,
Yeah.
we see a clear hallucination.
Right. So it's more specific.
Exactly. And as they expanded the training data set, the benefits of this segment level approach became even more pronounced.
So it's not just about having the right data.
Yeah,
It's about analyzing it at the right level.
exactly.
That's fascinating.
It is.
We've covered so much ground already.
I know, it's a lot to take in.
What else do we need to know about Realign before we wrap things up?
Well, we've really explored the inner workings of how it mitigates hallucinations.
Yeah.
But the story doesn't end there.
Okay.
In the final part of our deep dive, we'll step back and discuss the broader implications.
All right. Sounds good. Okay. So we really dug into the nuts and bolts of Realign.
Yeah, all the technical details.
And it's clear that it's really effective at tackling these VLM hallucinations.
For sure.
But now let's kind of zoom out a little bit and think about the bigger picture.
Yeah, the broader impact.
What does this actually mean for the future of VLMs?
I think the most exciting thing about Realign is that it's not just like a Band-Aid solution.
Yeah.
It's really addressing the root of the problem.
So instead of just fixing the symptoms, you're going for the underlying cause.
Exactly. It's tackling that core problem, that misalignment between what a VLM sees and what it says.
Right.
And by doing that, you know, creating those hallucination traps
Yeah.
and training them to avoid those traps,
Right.
you're essentially teaching them to be more discerning.
Okay, so it's like giving VLMs a healthy dose of skepticism.
Yeah.
Be like, hey, don't believe everything you see right away.
Yeah, look closer. Think it through.
Think critically about this.
Exactly. And as we've seen, it's not just about reducing those nonsensical outputs. It's about improving performance on, you know, general tasks as well.
Right, so it's unlocking their true potential.
Yeah, grounding them more firmly in reality.
Okay, so we talked about some of the applications before.
Yeah,
Autonomous driving, healthcare robotics.
right.
But I imagine it goes way beyond that.
Oh, absolutely.
What other areas could this impact?
I mean, think about education.
Yeah.
You know, students could use VLMs to explore historical events
Yeah.
through interactive simulations.
Oh, wow. Yeah, that'd be amazing.
Or imagine scientists using them to analyze these complex data sets
Yeah.
and uncover patterns that we would never be able to see.
It's almost overwhelming to think about all the potential.
It is.
But then it also brings up this question of, as these models become more powerful,
Yeah.
how do we make sure they're used ethically?
That's the big question. It's something that we all need to be thinking about.
Yeah.
Researchers, policymakers,
So
everything.
it's not just about the technology.
Right.
It's about making sure we have the safeguards in place.
Exactly. We need those robust frameworks and guidelines.
Yeah, for responsible development.
Absolutely.
Okay, so what's next for research in this area?
Well, I think one area is making Realign even more efficient.
Okay.
You know, creating those data sets can be computationally expensive.
Yeah,
So streamlining that process would be huge.
right. So making it easier for people to use.
Exactly.
Okay, what else?
Well, another interesting direction is adapting Realign to other modalities.
Okay, beyond vision and language.
Yeah. Could we apply these same principles to audio data
Yeah.
or even tactile information?
Wow, so expanding it to other senses.
Exactly. And that could lead to some truly amazing applications.
Yeah, it feels like we're just scratching the surface here.
We really are.
It's exciting to think about where this could all go.
Yeah, it's a fascinating field.
Well, this has been a fantastic deep dive into Realign.
Yeah, we covered a lot of ground.
We talked about the technical details, the potential benefits, the ethical considerations.
And the future?
And the future.
It was great unpacking all of this with you.
Likewise, and to our listeners, definitely check out the full paper.
Yeah, there's so much more to explore.
And as always, keep learning, keep exploring.
Stay curious.
The world of AI is constantly evolving,
It is.
and we're all on this incredible journey together.
That's right.
So that wraps up another episode of The Deep Dive. Until next time.
See you then.